Hello class, in today's video we're going to be reviewing over statistical graphs. The learning intention of today's video is we're going to review the types of graphs that can be used to display both categorical as well as numerical data. We're going to know how to construct a frequency table so that we can actually represent that on a histogram. And finally, we're going to know how to find the measures of center, mean, and median for a set of data. During our last lesson, we talked about surveys having the potential to provide us really good information for us to understand things better. We said that the data could either be categorical, where we are provided with generally descriptive answers, or it could be numerical data where we actually obtain numbers that we measure or record. However, there are specific types of categorical numerical data, and this could be either an ordinal, nominal for categorical, and for numerical data, it could either be discrete or continuous. Now, in today's lesson, I'm going to be showing you the visual displays for both categorical and numerical data. So let's look at what the visual displays for categorical data. So when we are representing categorical data in a graph, you could either represent this by showing a bar graph, or you could either show this using a pie chart. So these types of graphs over here, you've probably done this earlier during your high school life, so probably in year 7. So this is when you were drawing your bar graphs on pie charts. We're not really going to be looking at them in a great detail at all. We're just going to be just overviewing them, just a quick review. But I do want you to understand that a bar graph is different from a histogram. As you can see over here, a bar graph shows categorical data, but also if you look along the x-axis, each bar or each of those little peaks are separated with a little gap. Now, when you're trying to display numerical data, there's actually various forms that you could actually opt for. You could either show this using a histogram, a stem and leaf plot, a dot plot, or a box plot. And I just want to let you know that each of these individual types of visual displays have their own advantages and disadvantages. But you should probably be aware that the histogram and box plot are probably the most commonly used because they have a lot more advantages compared to the other ones, which is the stem and leaf plot and dot plot. But the focus of today's lesson is we're just going to be looking at the histogram, stem and leaf plot, and dot plot, and we're going to look at box plot in the next video. We're now going to be looking at frequency tables and how we could actually construct them. Before that, I want you to quickly answer this question over here. So give yourself a minute or so to answer this question. What I want you to do is I want you to label the table to show which data set is discrete or continuous. You don't need to actually construct this table at all. Just identify which one represents discrete and which one represents continuous. On the left hand side over here, just for context, this over here is representing shoe sizes. Whereas on the right hand side of here, this over here is representing temperature. So give yourself 30 seconds or so and answer this question to see whether your answer matches up with mine. Now, if you've done this correctly, notice that the values on the left hand side takes on fixed values that kind of go up by 0.5s each time. So because there's a fixed increment, the left hand side shows discrete data, whereas on the right hand side for temperature can take on any particular value. So therefore, this is an example of continuous data. Now, when we collect data, it's going to be in a raw form where it's quite unusable, where we can't really make any interpretations at all from it. So what we do in order to organize it so that we can actually interpret the information is that we actually export it or extract it into a frequency table, something similar to this over here. So on the left hand side of here, this shows you the numbers, and on the right hand side, you generally have the frequency, which indicates both the number, so how many times it occurred, as well as its percentage. So a frequency table is used to organize and display numerical data. It helps us to condense and transform the raw data into a usable form that can be interpreted more readily. So for instance, if I was to export all this raw data for shoe sizes into a frequency table, this is what it would look like. So it's not the complete thing, but I'm just showing you the first 4 numbers, the first 4 lowest numbers, starting from 5. There is 1 value there, and if I was trying to find the percentage, it would be the frequency divided by how many data values there are in total. So in this case, there are 16 values, and since I'm trying to find a percentage, I'll multiply it by 100, and that's how I obtain 6.25%. I'll do the exact same thing for each data entry, and I'll just fill the rest of my table. Similarly, if I was to put the raw data for temperatures into a frequency table, this is this is what it would look like. Now notice over here that your frequency table don't have to go up by the same amount, because this will be dependent on what values you obtain with the raw data that you receive. Now, what I'm showing you on this particular slide is what would happen, or what would it look like if I was to draw the complete frequency table for the data set showing the temperatures. Now, notice over here that the frequency table is quite long, and the reason why we generally don't draw a frequency table where we list down all the individual values within the data set is because this is firstly tedious and it takes just too much space. So what we actually do is, just to make this a bit more organized, a bit more simpler, is that we actually chunk this, or we actually group the data values into convenient class intervals. So class intervals are just smaller group sizes. So frequency tables that chunk numerical data into smaller groups are what we refer to as grouped frequency tables. By grouping values into smaller groups or class intervals, data becomes more understandable. And the size of the class intervals that we often use are multiples of 5. So for instance, it could go up by 5s, it could go up by 10s, 15s, 20, etc., etc. And generally, if the question is not telling you what class interval that we have to use, you have to come up with an appropriate class interval. And we'll be going through some examples later on to show you what an appropriate class interval looks like. So in the following examples over here, you've got these values over here. Now notice this is an example of continuous data, because they have, firstly, there's decimals, and these decimals can take on a wide range of values. And what they've done is, instead of listing each individual value down the first column, they've actually grouped them up together. So starting from 30, it's going up by 5s each time. So this is increasing by 5 each time, and this should always be consistent. So it's going up by 5 this time, and then again, you just write down the frequency, find the total, as well as its percentage. Now, generally, the percentage of all your data set should equal to 100%, but oftentimes when you do have decimals and there's rounding up issues, then your percentage could either be just slightly below it or slightly above it. It's not a big issue at all because of that rounding issue. Now, on my right-hand side, I've got a question which asks us to create a frequency table where we need to divide the data into 5 groups. Now, there are a few things that you need to consider when you're asked a question to develop a frequency table. Firstly, you need to ensure that the size of each class intervals are the same, meaning that you go up by 5s, you go up by 10s each time consistently in the frequency table. You also need to ensure that you've chosen an appropriate class interval, if not instructed. You need to ensure that you group data into the required number of class intervals or groups. So in this case over here, it's asked us to divide it into 5 groups. You also need to ensure that the class intervals do not overlap with each other at all. And I'll show you an example soon to demonstrate what I mean by this. And lastly, you need to ensure that there are no gaps whatsoever between their intervals. Now, to better understand what constitutes a really good frequency table, I've got an example on the right-hand side of here that shows a common frequency table that students often make, which is incorrect. Now, if you actually look very closely, the reason why this particular frequency table is incorrectly done, although it's not complete, is because it's actually going up by the incorrect amount, or the size of each class intervals is not the same. So in this case over here, notice this over here actually has 6 values, starting from 0, which is included, to 5. That's 6 values. 6 to 5 contains 5 values. 11 to 5 contains 5 values. So because they don't, the size of each class intervals or the groupings of each class intervals are not consistent, therefore this particular frequency table is done incorrectly. Now, for my second example over here, what is wrong with this particular frequency table? If you guys look closely at this one over here, if I was to group them up into just 2 subgroups over here, this is done incorrectly because this is an inappropriate size for the class intervals. Obviously, if you're going to make the size of your class intervals much larger, you're going to have a lot of data only between 1 or 2 subgroups, and that wouldn't provide us much information at all. So as a result of that, you need to choose an appropriate class intervals where you have generally about 3 to, let's say, 5 to 6 bars. And if you don't have that required amount, then you're going to get less information that way. In my third example, what's wrong with this particular frequency table? Now, if you guys look closely with this particular example over here, notice that there is an overlap. So for instance, if I had a data value of 5 and I constructed my frequency table like this, the number 5 would then be going under this category as well as this category over here. And as a result of that, because 5 goes into both groups, in this case, your data value is not going to be very accurate at all. So that's what I mean by we should not have any overlap by class intervals. So that's something that you also need to be mindful of. And lastly, the error with this particular frequency table is that you're actually missing the class interval 10 to 14. So we do not skip class intervals at all when we're drawing a frequency table. If there's no values that lie between 10 to 14, hypothetically, then you just put the number 0 as your frequency. So what I'd like you to do now for the next 5 minutes is I'd like you to have a go and construct a frequency table for the data set shown on the left hand side. The question wants you to use class intervals of 10, meaning that this you need to chunk it into tens, but also calculate the percentage frequency column. Now for this particular example over here, I recommend that you start from the number 0, and remember 0 is included, so it will be 0 to 9. Etc, etc. So have a go with answering this question and then compare your answers with my answers. Now, if you've done this correctly, this is what your answer should look like. So from 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49. And in the last one, you should always generally indicate the total. So in this case, if you have this number 20 should represent the number of values that are, which is specified by the question already, and you should generally get 100%. If you don't get 100%, that means the calculation you've done up above is probably incorrect, so you need to re-look into that. What we're going to be looking at now is we're going to be looking at histograms and drawing histograms. So histograms is a visual display where we show numerical data for both discrete and continuous. This is the main advantage of drawing histograms as opposed to the other visual displays such as the stem and leaf plot and such as the dot plot. Because for histograms, you can show continuous and discrete, whereas the other ones can only show discrete data. Now, most students often get confused between histograms and a bar graph, but one of the main fundamental differences between a histogram and a bar graph is that firstly, a histogram, there's generally no gaps at all, but in a bar graph, there are gaps to separate each different type of categorical data, whereas histogram shows numerical data in this instance. Now, once we've already constructed our frequency table, we can actually draw a histogram quite readily. And there are a few things that you need to be mindful of when you're drawing a histogram. Firstly, the class intervals are always going to be represented along the x-axis. The frequency, the percentage frequency, or both of these can actually be shown and represented along the y-axis. You need to ensure that there are equal intervals along the x and y axis. So what does that actually mean? Well, in this case of here, make sure that each of these are going up by the same amount. So in this case of here, they're going up by tens in this case over here. And the same thing needs to be this, and the same thing also applies along the y-axis. So in this case of here, they're consistently going up by the same amount. So it's a fixed increment of 100 in this case. And lastly, this is something that most students often forget when they're drawing the histograms, where they lose marks on, is labeling the actual axis. So in this case, this has a label of here, which is salary, and the units in this case is in $1,000. And along the y-axis, generally this is the axis for your frequency, but in this example, it is frequency of employees. Now, for those who don't understand what I mean by, this dot point over here, this is what I mean. So in this case, if you notice that our particular histogram shows both frequency as well as percentage frequency. Now, this is generally uncommon. It's usually one or the other, but if the question did specify you to include both frequency and both percentage frequency, you draw one on the left-hand side, you draw the other one on the right-hand side. This is how we actually would do it. Something that you also need to note is that when you're drawing a histogram, you don't necessarily have to start from the value 0 at all if there's no values starting from 0. So in this case, if you look at the example on the right hand side, we generally draw a little zigzag sign of here if we're skipping the very first few values. So in this case, I've skipped the first 180 values because there's no values that fall within that range. So I draw that little zigzag, and that would indicate that I've skipped it, and now I start from 180. So please ensure that you are drawing a little zigzag if you are skipping values. Otherwise, you're generally going to be losing a half a mark or so. Now, what I'd like you to do right now is, using the exact same example from before, I'd like you to please construct a histogram from your previous grouped frequency table. So what I'd like you to do is, I want you to draw a histogram that shows both the frequency as well as the percentage frequency. So on the left hand side of the y-axis, you're going to represent it using frequency. On the right axis, then you're going to be representing with percentage frequency. So give yourself 5 minutes to roll it up neatly and everything, and then see whether your answers match with my answers. Now, if you've done this successfully, this is what your histogram should look like. So in this case over here, I've labeled my axes. The increments are the exact same, so they're going up by 10 in this case. The increments along my y-axis are also the same, that goes up by 2. On the other y-axis, this goes up by 10. So this is how you should be drawing your histogram. We're now going to be looking at the other uncommon forms of visual displays for numerical data, which is dot plots and stem and leaf plots. So a dot plot is pretty much very similar to a histogram. Now, a dot plot is a graphical display which only is used to display discrete numerical data. It's not compatible to show continuous data which takes on decimals, because it's just not very viable at all. Now, it is very similar to a histogram, but instead of representing the values with bars, each data value is represented by a dot. So in this case over here, if this is my data value here, notice that I've got one value that is equivalent to 0, so I only have one dot, etc., etc. In comparison, a stem and leaf plot is a special table where each data value is divided into a stem, and generally the stem is usually the first digit, but I'll show you an example where the stem could be 2 digits, and a leaf where the leaf is always going to be the last digit. So for instance, if this is your data set over here, and if you were to put this into a stem and leaf plot, as I said on the description above, generally the first value is going to be your stem, so the value on the left hand side, and then the value on the right hand side is going to be your leaf. So therefore you put 2 over here. Since you've got 2 values that are 30 within the 30 range, that's why 0 is over here and then the 2. So that's why I said in example 32 is split into 3, which is the stem, and 2, which is the leaf. Now, it's really important that when you're drawing a stem and leaf plot, you need to actually indicate a key, because it helps readers who are unfamiliar with this visual display to actually interpret and make sense of the data. So for instance, you can make a key for any value, but in this case, since we're using the value 32, I would say the key 3-2 means 24, because generally we draw our stem and leaf plot like this. So therefore, this line over here represents this over here. Now, in this particular example, I've shown you a stem and leaf plot where the stem actually comprises of 2 numbers. So in this case, if you've got a value like this over here, 14.5 in this case over here means 145. So that's just something to note. A stem and leaf plot doesn't necessarily have one single value for your stem. It could be 2 as well. We're now going to be looking at the second last part of today's lesson, which is looking at measures of central tendency, aka looking at how do we actually work out the average. Now, there's a common misconception where students often think that the word mean is the same thing as average, but average could just mean could also mean the median as well as the mode as well. So 3 ways to actually indicate the central value of a data set. This could be obtained by calculating the mean, the median, or the mode. And each of these 3 have a slightly different definition and way to actually work it out. The mean is often referred to as the balance point, and I'll show you what this means later on. And the way that we calculate the mean is by finding the sum, meaning you add up all the values in the data set and then you divide it by that amount of number. The median, on the other hand, is what we refer to as the middle value of a data set, and this can only be achieved or calculated when we arrange numbers from smallest to largest, so in ascending order pretty much. And the mode, I'm pretty sure most people still remember what this is, but that's calculated or found out by finding out what is the most common value in that data set. Now, on the right-hand side over here, I've said that the reliability of each of these 3 measures to represent the average or the middle value or the central value of a data set is often determined by the shape of the data set. And I'll talk to you guys what I mean by this later on. So over here, I've got different shapes of the distributions or different shapes for a data set. It could be normal distributed or it could be symmetrical. So symmetrical is often used instead of normal, but they're both used interchangeably. When you've got a histogram, it could also be bimodal, meaning that you've got two tall peaks. It doesn't necessarily have to be the same height, but if it's clearly stands out from the rest of the data set, then you've got a bimodal shape. This is what you're going to have to be familiar with. So this term over here. So your data set could either be symmetrical or it could be skewed. More specifically, it could be negatively skewed, and a negatively skewed data set is one where your tail over here is a lot longer, your lower tail is a lot longer than your upper tail, whereas a positively skewed is where your upper tail is a lot more longer than your lower tail. So these tails are just imaginary tails, but we usually use them so we can distinguish whether something is going to be positively or negatively skewed. So in this example of here, what I'm trying to show you is that with where you see the ticks, that's showing you when that particular measure of center or way to work at the average is more accurate. So when something is symmetrical, you often want to use the mean instead, but when something is negatively skewed, you'd rather use the median in this case, as well as for positively skewed as well. We generally in this case don't use the mode at all, but if you did have bimodal, then I'll be using the mode as a way to calculate the average value and finding the midway point between those two perhaps. So what I'm going to be doing now is going through some examples of how I'd calculate the mean, median, as well as the mode. So in the first example, calculate the mean for the following data set. So this is a pretty easy one. So all you have to do, as I said earlier on, is we have to add up all the values and divide it by the number of values. In this case, the number of values is 4. So if I did this correctly, 20 divided by 4 is going to give you 5. So your mean is 5. Earlier on, I did discuss that the balance point is considered to be, the mean is considered to be the balance point. So I'll show you this diagrammatically to show you what I mean. Now, if I was to show all these values on a little seesaw, this is what it would look like. Notice that all of these values over here are now balanced when your mean is actually at the value of 5. So when it's 5, all the values are balanced, so therefore 5 is the correct mean in this instance. Now this is going to go slightly above what we need to know for this course, but I'm just going to show you what would happen if I place another block on the number 8. So using our current data set, what happens if I introduced another value and that value is equal to 8? Now, you probably know that if you add another value, now the balance is now going to be tipped to the right-hand side. So now, therefore, this would indicate your mean is no longer going to be 5 at all. Since your mean is no longer going to be 5, what would you expect the mean to be, the new mean to be? Would you expect the new mean to be lower or higher? Now, if you had these tactile materials with you, you would agree with me that if I slided this balance point or to the right in this case, this will balance the actual scale. So therefore, our mean needs to be higher in order to actually balance our new data set in this case. We're now going to be looking at how to calculate the median. So what I have over here is I've got the values in the form of a stem and leaf plot. Now, this might be a bit different to how you would normally answer this question, but I can assure you it's the exact same thing. What we need to do is that to calculate the mean, we need to actually order numbers from smallest to largest. And then once we do this, then we can cross the numbers from the outside and then progressively move inside until you get one value. So if I was to write down all the values from my stem leaf plot into the raw form, this is what it would look like. Because I know that if I was to interpret this, 0, 1 just means 1. 0, 3 just means 3 because the 0 is a placeholder. It doesn't hold any significance. And the next value therefore should be 12, etc., etc., etc. Now, once you've done this, then cross the numbers from the outer ends and progressively moved in the inside. So if I did this, this is what it would look like. So just keep moving, and once you reach one value, or once you reach two values in this example of here, what you actually need to do is you actually need to find the middle values of the two most innermost values. So find the midpoint in this case, so the midpoint between 19 and 21. So you add both of these values and divide it by 2, and that will therefore give you 20. But in this particular example over here, it's quite easy to determine that a number that's halfway between 19 and 21 is therefore going to be 20. But in some difficult examples, it's not going to be as obvious. So therefore, you will need to show this particular calculation over here. We're now going to be moving on to the last part of today's lesson, which is about describing the shape of a histogram or the shape of the data set. Now, I've shown you this earlier on, but there are only three main types of shapes that you need to be aware of. This is the symmetric, or this could also be referred to as the normal, but we generally use symmetric because that's what the textbook goes by. There's also negatively skewed and positively skewed, and down on the below on each dot point, I've kind of shown you how do you actually distinguish between each one. Now, when something is normally distributed or when it's symmetric, the length of the upper tail is the same as the length of the lower tail. So these tails are just imaginary. So if you've kind of identified or eyeballed where your median is going to be, this over here represents your upper tail. This over here represents the lower tail because it's lower than your median in this case. Now notice over here that the length of your upper tail, the length of the lower tail are approximately the same. And because they're kind of equivalent, this is referred to as symmetric. If we look at negatively skewed, look at where your median is. So look for where your tallest peaks. Now notice over here, if I was to draw an imaginary lower tail, this is what my lower tail look like. This is what my upper tail look like. Notice that your lower tail over here is a lot more longer than your upper tail. And when this is the case, this is an example of a negatively skewed, whereas it's the opposite for positively skewed. Notice that now that your upper tail is now significantly longer than your lower tail, so therefore this is an example of positively skewed. Now I want you to have a go to identify the shape for this particular histogram. So give yourself 30 minutes, refer to the notes from the previous slide to identify what the shape of this histogram is. You don't necessarily have to draw it into your exercise book, but if you could, then that would be great. Now, if you've done this correctly, the shape of this particular histogram is going to be negatively skewed. Now, notice in this case, your lower tail over here is a lot longer than your upper tail, so therefore it's going to be negatively skewed. What I'd like you to do for the remainder of this question of the lesson is answer questions 1, 2, 3, 4, 6, and 7. So on this particular slide, I've shown you questions 1 all the way to 4. And once you've answered questions 1 to 4, then answer questions 6 and 7. If you've done this successfully, I want you to please self-assess yourself to see whether you're doing it correctly with the answers on this particular slide over here. After you've done that, then I'd like you to please complete this particular exit ticket on Google Classroom once you've completed and submitted to me all your textbook questions. This is the end of today's video. Hopefully you guys enjoyed it. I'll see you guys again in the next video. Bye.